very major section that we're going to repeat only in 14th chapter, that we have two types of waves, mechanical waves and electromagnetic waves. Mechanical waves are those waves which depends on the medium for its traveling. An electromagnetic wave is the one which is independent of medium. Before getting into the types of wave, let me redefine what wave is. तो हम wave को define करते हैं. It's a phenomena which transfers energy without transporting medium. ठीक है? A wave is a phenomena which transfers energy without transporting medium. There are two major subtypes of mechanical waves and electromagnetic waves, which are sound and light. We are familiar with these two. These both are the types of waves which transfers energy without transferring any medium. For example, if I'm talking to you, only my sound is reaching to you. No kind of matter is reaching out to you. This means that wave is a phenomena which only transfers energy but does not transfer matter across it. Clear?
हाँ जी।
Wave is divided into two parts, mechanical wave and electromagnetic wave. जो medium dependent होते हैं waves, those are known as mechanical wave, and the ones which are medium independent are known as electromagnetic waves. The example of mechanical wave is sound, because sound requires a medium. हमने discuss किया था ना in the previous chapter that if we remove the air from the jar, we will not be able to hear the sound of the bell, because now there is no air present, which means no medium is present, so we will not be able to hear the sound. ठीक है? So sound is a type of mechanical wave, which means it is medium dependent, and light is an electromagnetic wave, which is it is medium independent, that it does not require any medium for its propagation. It could move through vacuum as well. Okay. Mechanical wave is further divided into two types, longitudinal wave and transverse wave. Longitudinal waves are the one in which the vibration of the particle and traveling of wave is parallel to each other. And transverse wave is the one in which the oscillation of the particle is perpendicular to the motion of the wave. For example, if I take a spring, okay, and attach it to some solid surface, and now I move the spring back and forth like this. Okay. Now, as I move the spring like this back and forth, so we will have this kind of wave is known as longitudinal wave. But if I move the spring up and down like this would be known as longitudinal, and this is known as transfer. ठीक हो गया? Or take a rope, attach it to one end, and now move the rope up and down like this. Now, the vibration of the particle or the oscillation of the particle, किस direction में है? सबसे पहले let me re-explain to you. Vibration और oscillation का meaning क्या होता है? Oscillation or vibration means back and forth motion of the object. Am I clear about vibration and oscillation and transverse and longitudinal? Longitudinal में क्या होता है? Particle motion back and forth होता है. ठीक है? Particle motion is back and forth. That is, अगर मैं ये particles draw करता हूँ ऐसे, everything is made up of atoms ना, ठीक है? Solid or liquid or gas, everything is made up of something, ठीक है? अगर all particles are moving like this, back and forth, तो ये longitudinal होगा. ठीक हो क्या? अगर particle ऐसे up and down move कर रहा है, like this, तो this type of motion would be known as transverse wave. थोड़ा थोड़ा क्लियर हुआ कि ट्रांसवर्स लॉन्गिट्यूडनल में डिफरेंस क्या होता है? पार्टिकल के मोशन का
हाँ
होता है बस। ठीक है, लेट मी शो यू हाउ इट लुक्स लाइक। अगर मैं हैंड की मूवमेंट अप एंड डाउन करता हूँ और इस तरह की वेव जनरेट हो, ठीक है, सच अ टाइप ऑफ वेव इज नोन एज ट्रांसवर्स वेव। एंड अगर मैं स्प्रिंग को ऐसे बैक एंड फोर्थ मूव करता हूँ, तो अब कंप्रेशन रेयरफेक्शंस हम लोगों ने ऑलरेडी डिस्कस किए हुए हैं। ठीक है, दिस कंप्रेस्ड पार्ट ऑफ द वेव इज नोन एज ये compressed part is known as compression and this stretched part is known as rarefaction. So longitudinal, अब डायरेक्शन ऑफ मोशन देखो दोनों में सेम ही है। ठीक है, इसमें पार्टिकल मोशन इज परपेंडिकुलर और इसमें पार्टिकल मोशन इज पैरेलल टू द मोशन ऑफ द वेव। सो पार्टिकल का मोशन आपको आइडेंटिफाई करना है। देखो बैक एंड फोर्थ है, इसमें अप एंड डाउन। ठीक हो गया। अब इनकी एग्जांपल्स आपको आनी चाहिए। लॉन्गिट्यूडनल वेव की डेफिनेशन में साउंड आ जाता है एंड पी सेसमिक वेव्स आ जाती हैं, जिनको पी वेव्स भी कहते हैं। सेसमिक वेव्स अर्थ वेव्स को बोलते हैं, अर्थक्वेक की जो वेव्स होती हैं उनको। ट्रांसवर्स वेव में रिपल टैंक आ जाएगा, लाइट आ जाएगा एंड एस सेसमिक वेव्स, सेकेंडरी सेसमिक वेव्स आ जाएंगी। ये एग्जांपल्स आपको आनी चाहिए। ट्रांसवर्स वेव की डेफिनेशन इज राइट इन फ्रंट ऑफ यू, यू कुड सी इट हियर, दैट ट्रांसवर्स वेव इज द वन जिसमें movement of particle is side to side at right angle to the, and longitudinal wave is the particle carrying the move back and forth along the direction of the propagation. And you must remember these examples as well and these drawings. Clear? बाकी हम लोगों ने एम्पलीट्यूड्स वगैरह को प्रीवियस लेक्चर्स में ही डिस्कस कर लिया था, इफ यू रिमेम्बर। ये मेरे पास टाइम पीरियड है, टाइम पीरियड कहाँ तक होता है? ये भी हो सकता है, ये भी हो सकता है, ये भी हो सकता है। मैं एक वेव से जहाँ से स्टार्ट करूँ एंड देन एग्जैक्टली ऑन द सेम पॉइंट ऑन द अदर वेव, दिस वुड बी नोन एज टाइम पीरियड। टाइम पीरियड को डिफाइन हमने कैसे किया था? इट इज द टाइम रिक्वायर्ड बाय द वेव टू कंप्लीट वन ऑसिलेशन। ये लिखा हुआ है, टाइम टेकन फॉर कंप्लीट वन। अब वन वेव हम उसको यहाँ से यहाँ भी ले सकते हैं। अगर हम उसको, मैं इफ आई एम स्टार्टिंग फ्रॉम हेयर एंड आई ends up here, this is also the time period. ठीक है, if I start from this point, ठीक है, so next wave की exactly इस point पे आके मेरा एक complete होगा, this would also be known as time period. It is only the time required by the wave. Similarly same goes for the wavelength as well. Wavelength क्या होता है? distance between, अब इसके अंदर crust कौन सा है हमारे पास? crust ये है,
ऊपर वाला।
trough, trough ये है हमारे पास। ठीक है, so distance between a crust or trough is one wavelength, or distance between two consecutive crust or two consecutive troughs, or exact the same way, if I start from this point, I'll end exactly at this point on the other wave, this would be one wavelength. Wavelength is represented as lambda, ठीक है, and its unit is meter. Time period is represented as t and its unit is second. And now comes another topic, which is frequency. Frequency क्या होता है? Number of waves passing through a point in 1 second. How many waves do you see here? 1, 2, 3 and approximately 4. ठीक है, तो the frequency would be 4 hertz. Let's say it's a complete wave, बस cut हो गया यहाँ पे. So number of waves passing through a point in 1 second is known as frequency. Here is the definition. Frequency has a unit of 1 over second or hertz. वेवलेंथ की डेफिनेशन ये लिखी हुई है हमारे पास। एम्पलीट्यूड हमारे पास क्या होता है? मैक्सिमम डिस्प्लेसमेंट ऑफ द वेव। हियर उन्होंने वेवलेंथ भी शो किया हुआ, इट्स द वेवलेंथ, एम्पलीट्यूड, वेवलेंथ, टाइम पीरियड एंड फ्रीक्वेंसी यहाँ पे हम लोगों ने डिस्कस कर लिया। दीज आर द टर्म्स विच आर एसोसिएटेड विद वेव्स इन पर्टिकुलर। ठीक हो गया। अब ये रिपल टैंक होता है. This ripple tank is a device which we use to study the properties of waves. This is the vibrator. ठीक है. If this vibrator is attached, we get a wave like this. If I zoom it out, इस तरह के हमारे पास आएंगे. ठीक है. Straight. These are known as wave fronts. अब अगर मैं इसी के साथ एक पॉइंटर अटैच कर दूंगा, पॉइंटी एज को अटैच कर दूंगा, तो वेव्स हमारे पास कहाँ पे बनती हैं? इस स्क्रीन के ऊपर बनती हैं. ये हमारे पास ग्लास स्लैब होता है. अबव इट वी हैव वाटर, वाइब्रेटर एंड लैम्प. The reflection of the waves are built on the screen, and from there we study everything, the amplitude, the properties of everything that is associated with this is known as wavefront. Bit keep this in your mind. This line, this line, and this line, and this line. These are plane wavefronts. And these are circular wavefronts. See? इनको spherical wavefronts भी कहते हैं. Normally, naturally, जो wavefronts आते हैं, they looks like this spherical wavefronts. And हमने wavefronts के बारे में in the previous lesson we have discussed in detail कि what a wavefront is. कि क्या define करते हैं wavefront को? The way wave travel across the medium. ठीक है. एक wavefront से next wavefront तक का distance क्या होता है? One wavelength. Always keep in your mind. For example, अगर wavefronts ऐसे है ना हमारे पास, like plane wavefronts, आगे जाकर हमें properties of waves पढ़ना है ना, उसके अंदर ये तमाम चीजें repeat होंगी. So one wavefront to next wavefront is one wavelength. ठीक हो गया? अगर spherical wavefronts है like this, तो one wavefront to next wavefront is wavelength. One wavelength. Okay? So ripple tank is a device which is used to study the properties of waves. We have two types of wavefronts, plane wavefronts and circular wavefronts. And wavefront is an imaginary surface. हमने क्या define किया था wavefront को? It is an imaginary surface on which each particle is in the same phase of vibration. Do you recall that? Let me write the definition for you again.
डेफिनेशन दे लिख लिया
Wave. जी?
लिख लिया
हमने वो साउंड वाले क्रम में किया हुआ है. मैं सिर्फ चूंकि दोबारा यहाँ पे आ रहा है तो मैं बस दोबारा बता रहा हूँ. An imaginary surface on which each particle is in same phase of vibration. Suppose these are the particles. They are attached by an imaginary surface. If they all go up together and comes down together at the same instant together, such a type of imaginary surface is known as wavefront. And this is how waves travel across the mediums. ठीक है? This is how wave travel across the medium. अब हमने वेव को डिस्कस किया, वेव की डेफिनेशन को. वेव क्या होता है बताओ? The phenomena in which that is how the medium affects the speed of the wave and the properties of the waves that are changed due to a difference of medium. ठीक हो गया? अब in order to understand that, we need to go back and see the formulas for frequency and time period. Frequency is given as 1 over t and time is given as 1 over f. If we need to recall the formula for speed, speed is given as distance over time. In case of waves, this distance is replaced by wavelength. So it would become lambda over t. We know that 1 over t is given as frequency. So v is equals to f lambda. So this is the wave equation. Speed is equals to frequency into wavelength. Okay. This is known as the wave equation. Then comes how. Acha, there is one thing that you need to keep in your mind is whenever we're discussing the wave properties, there are three properties that we take into account. One is reflection, and third is diffraction. Once you get a good hold of this topic and know how to draw these diagrams, हलवा है बिल्कुल ये टॉपिक. ठीक हो गया? V is equals to f lambda. अब इसमें आपने एक ये माइंड में रखना है, if frequency is kept constant, frequency is kept constant, the speed is directly proportional to wavelength, which means if speed is increased, wavelength would be increased. अब उसने ये हमें कहा है कि अगर हमारे पास if a wave enters into a denser medium, that is from air to water or glass, देखो, when it is entered from air to glass, the wavelength would be reduced if frequency is kept constant. We can see here the speed would decrease, so does the wavelength. That is distance between the crust. We could see the distance has decreased. But this you only need to keep in your mind for the wave properties only. Whenever we go to sound and light and other electromagnetic waves, these properties does not apply there. It applies there, but in that context, we do not discuss to keep the frequency of the wave constant. ठीक हो गया? The next topic is the refraction and diffraction of waves, which we'll do all together in the next lesson, and that would be the end of this chapter. Okay? Now go ahead and review the whole chapter.